Hello students, this is the first video of chapter 4 moving charges and magnetism. Our first topic is Oersted's experiment. Now this is a magnetic needle or magnetic compass. Okay, let me draw like this. This is a magnetic compass. The needle is a small magnet. This is a magnet actually. Okay, so magnet always aligns itself along north south direction. You know this. Now take a wire which is parallel to the needle and just above the needle. The wire is just above the needle. This is the needle and this is the wire. Suppose wire is above the needle, so it is also directed north south because the wire and the needle, they are parallel. Now Oersted observed an interesting phenomenon. When current is allowed to pass through this wire, the needle is actually get deflected. Okay, it deflected towards west. When there is no current, there is no deflection in the galvanometer, in the compass needle. But when current passes through the wire, the needle gets deflected. So current carrying wire produces deflection, means what? Current carrying wire produces magnetic field. That magnetic field deflects this magnet because one magnet can affect the other magnet. So the conclusion is, when current passes through a wire, a magnetic field is produced in a surrounding. That magnetic field affects this magnetic field. So this is the Oersted's experiment. So what are the conclusions of Oersted's experiment? Number one conclusion: current carrying conductor produces magnetic field in its surrounding. Now you increase the current, you will see deflection is more. What does it indicate? More current, more magnetic field. So magnetic field increases with current. Next, you change the direction of current. Instead of sending current along this, you just send the current in the reverse direction, in the opposite direction. You will find deflection also in the opposite direction. You see, when current is flowing along this, deflection is towards this. When current is along this, deflection is towards this. So when direction of current has changed, the deflection also has changed. So we can write direction of magnetic field changes with the direction of current. Now in which direction the needle will deflect? The deflection of needle is given by two laws. One is Snow rule, other one is Ampere swimming rule. We will first discuss Snow rule. What is Snow rule? When current is flowing from south to north, S for south, N for north. Current is flowing from south to north, and the wire is over the needle, O. The wire is over the needle. Then the north pole of the needle deflect towards west, W. So SNOW, south, north over west. So when current is flowing from south to north and the wire is over the needle, then the magnetic needle deflect towards west. This is Snow rule. Now let us move on to the next topic, magnetic Lorenz force. These parallel lines represents uniform magnetic field. The strength of the field is, suppose, capital B. Intensity or strength of the field is B. A charge is moving through the field. Suppose charge Q is moving through the field. It makes an angle, suppose theta, with the direction of the field, and V is the velocity of the charge. A charge Q plus Q is moving with velocity V, making an angle theta with the magnetic field B. Then according to Lorenz, this charge will experience a force. And what is the force? Force is given by F is equal to Q whole into V cross B. It is in vector form, and in magnitude F equals to QVB sin theta. This is the magnetic Lorenz force. Now we discuss the special cases. stationary charge. If the charge is at rest, will it experience force? The answer is, if the charge is at rest means velocity is 0. Stationary charge means at rest means velocity is 0. When velocity is 0, then this force becomes what? 0. 0 into something is 0. So when velocity is 0, force becomes 0. So conclusion is, stationary charge in a magnetic field does not experience any force. Remember, stationary charge means charge at rest will not experience any force in a magnetic field. When the charge will experience maximum force? Force will be maximum if sin theta is maximum. What is the maximum value of sin theta? Maximum value of sin theta is 1. So when sin theta is 1, force will be maximum. When sin theta is 1, if theta is equals to 90 degree. So when the charge moves perpendicularly in a magnetic field, it experiences maximum force. So when a charge moves perpendicularly in a magnetic field, it experiences maximum force. So when the charges are moving parallel to the magnetic field, or in this case anti-parallel to the magnetic field, it experiences 0 force. Okay, it experiences 0 force. Our last topic is Lorenz force. Last topic for this video. Next will come in the next video. Now consider a charge in an electric field. Then the force due to electric field will be what? It is Q into E. This is the force due to magnetic field, electric field. Okay, and what is the force due to magnetic field? When a charge is placed in a magnetic field, the force due to magnetic field, we have just learned, it is V cross B. Now if you have a place where both the fields are present together, then what is the total force? The total force will be force due to electric field plus force due to magnetic field. You just add them. So total force is what? Force due to electric field plus magnetic field. Electric field is QE, magnetic field is Q, V cross B. Q is common, so E plus V cross B. This force is known as Lorenz force. So what is Lorenz force? It is the total force experienced by a charge placed or moving in a region where both electric and magnetic field exists. Thus Lorenz force is what? It is the total force on a charge moving in a region where both electric and magnetic field exists. So this is the first lecture on moving charges. Okay, the next topic will be discussed in the next lecture. Thank you very much.